Good afternoon, everyone. Uh, can somebody confirm if you can hear me clearly?
Yeah.
Yep,
Okay,
we can also see your screen.
thank you so much. I want to welcome you to my lecture today. Of course, today we are actually meeting on Zoom due to extreme uh weather. Before I get started, I want to say this in the course of our lecture, there's anyone who gets stuck or you need a clarification, I will advise that you ask questions. So I want this to be this lecture to be interactive. Okay, so be sure you ask me question. So today we're going to be starting what I called research design. And because I know under research design, we have experiment and observation studies. So we're going to be focusing more on experiments today. So what do we mean by research design? So I think I'm going to start from there. I remember when I was introducing you to this class, I told you about what this class is about. Uh, this class is about how you acquire consulting skills and how to communicate statistical or idea accurately. Because it is only when statistical ideas and results are communicated correctly that we can prevent misuse of statistics. So because of that, we realize that one of essential area that people don't get, well, that researchers don't get right is what we call research design. So by research design, we are talking about the overall plans that you put in place, that will guide how you conduct research, you know, to answer a research question in a credible, valid, and reproducible way. Because we want to believe that going into research, um, we have certain practical questions that we we want to answer, and how do we frame this in a way, that is actually going to be reproducible or going to be credible and valid. And not only that, I'm actually going to say it is the totality of steps that you take to ensure that you collect reliable data to facilitate correct analysis and thereby leading to a valid decision at the end of the day. So it's more or less like a plan. How do we plan our study? Because if we don't have a plan in place, uh, even if you make use of highly sophisticated method, it's never going to solve the problem. So, and that is why research design is very, very crucial. Now, I want to go into the the type of studies because in research design, we got two type of studies. We got observational study and experimental study. But you know what? We're going to be focusing on experimental study, but how four of us differentiate between the two. Now, when you talk about observational, studies, what do we mean? Okay, what we mean, here, the researcher does not control or assign the exposure or treatment. So what researchers do here, you know, they merely observe the differences in the explanatory variable. Let me say this. In research, we have, maybe we want to look into what is the relationship between this variable and that variable. So maybe you're trying to see relationship between uh, smoking habits and the risk of getting cancer. I'm going to say that again. Maybe in your research, you're trying to investigate relationship between smoking habits and the risk of getting cancer. So the smoking habit is an explanatory variable. The risk of getting cancer is outcome or response variable. So if you did not manipulate the explanatory variable as a researcher, or if you just take historical data, you just observe, what differences that we have in the explanatory variable. Of course, you are conducting an observational studies. Okay, but we just wanted to know, when you are conducting an observational study, okay, observational study cannot answer a question that has to do with causation. I'm going to say that again. Observational study cannot answer a question that has to do with causation. Okay, 1 second. I'm actually going to write what I mean. Okay, it cannot answer a question that has to do with this. Causation. What do I mean by causation? Okay, causation is when you want to answer a question on how a particular variable influences another variable. So it cannot be used to establish cause and effect. Okay, it cannot be. If, for instance, if you are using hospital record, where you have data on the smoking habit of patient, and you also have data on whether they eventually get lung cancer or not. Okay, so that kind of data, well, because you are using historical data, you as a researcher did not actually assign participants uh, to treatment. Uh, so that kind of study, you cannot even if relationship exists between uh, smoking habit and cancer, you cannot conclude that smoking habit actually cause cancer. You can't assume that. I mean, that is not going to happen. You can't make that conclusion because you are working with observational study. So, but on the other hand, when we talk about experimental study, okay, in experimental study, this is where the researchers have a idea, has an opportunity, to actively assign treatment, okay, to subjects. Okay, so when I say subject, or for instance, I'm actually referring to an experimental unit, the units that receive treatment. I may be talking about observation, maybe like patients. Okay, so I remember in 2020, there was an article published uh, in um, Weekly Journal of Medicine in the state of Massachusetts, and it was published by Pfizer. Pfizer company actually claimed they found efficacy. They found a vaccine for COVID. I think they claim 95% efficacy, and they actually explain how they arrive at 95%. They perform, there was before that very publication, there was a clinical trial conducted by the company, where they use uh, about 80,000 volunteers. They split them into two groups, and they assign the treatment, which is the dose. They assign the treatment to one of the group, and they assign the placebo. The placebo actually means that's used as a control to the other one. So in that situation, we can call that an experimental study because or the researcher actually creates differences in the explanatory variable. The researcher actually manipulates by assigning participants to treatment. So, and the record at the end of the day, I remember what they did. They actually vaccinated. They gave some group their vaccine, and the other group, even though this one also received something that looked like vaccine, but that was placebo with no effect, and they now expose the two group to COVID, and they actually, recorded the what is the number of those that get vaccinated with their vaccine that catch COVID. They compare that with the number of the other group that was given placebo, and at the end of the day, they realize that their vaccine work. So what they did, that was a clinical trial, that was actually experimental study. But let me tell you this, uh, experimental study can actually, we can conclude uh, causation with experimental study. Okay. And the reason why we can actually do that is because of the fact that um, randomization that take place, situation where the researcher randomize the subject to different treatment. Okay. And that's actually make it so the approach to have a very strong statistical power compared to the observational study. But let me say this, even though this particular study is actually come with a very huge statistical power, okay, it require resources, time, money, labor, and so on like that. Okay, and don't forget, when we conducting research, we have to put into consideration, uh, resources, budget, okay, and also efficiency. And don't forget, at times we could be limited by budget. Okay. Okay. So that is the difference between the observational study, okay, and the experimental study. Now, this is an example here. If I want to investigate the effect of aspirin on preventing heart attack, okay, we want to study, maybe we want to want to isolate the effect of aspirin, okay, on preventing heart attack. Okay, now if I want to perform experiment, or I want to embark on an observational study, of course, I'm actually going to show you how this can, I can walk you through the procedure. I'm actually going to start with the experimental study. Okay, don't forget, I said the other time, in experimental study, okay, that very study involve controlled treatment, assignment, and are designed to establish causality, So what we're going to do, just like the same way the FASA did it, where they actually partition a group of participants into two groups. So here we're going to assign half of the participants to take aspirin regularly, and we're going to tell the other not to take placebo regularly. But let me tell you this. It's not as if we're going to say a group should be doing that. We're actually going to randomize, okay, using instruction of chance in such a way that any of this group can be assigned to take aspirin regularly, and any of that group can be assigned not to take aspirin regularly. So here the researcher is in control. Okay. Now, after a while, after a particular group, have been taking that aspirin and the other group did not, then we're going to record whether the participants have attack during the follow-up period. So when you are doing that, you're conducting experiments. But if I want to go by way of observation and study, the researcher do not need to assign participants to group. What researcher can do is to interview participants. Okay, you're just going to interview participants or whether some of them are taking the aspirin or not. We can conduct a survey where you ask volunteers, do you take aspirin or not? I know somebody is going to say yes, the other person will say no. Then we have a record of those who take aspirin and those who do not. Then what we're going to do is we now record whether the participant have had attack during the follow-up period. So I wanted to take a look at these two. Okay, they are not the same. Okay, the observational study we interview participants and ask them whether they've been taking aspirin or not, and it's going to follow up to see whether the event of interest is going to happen. But in the experimental study, it's not going to ask whether they take it or not. The experimenter will be the one that will actually impose that on them. Okay, maybe the experiment, maybe the group they've not taken aspirin before is going to force it on them. Okay, and the other group is going to force them not to take aspirin and wait, in the follow-up period to see whether the event of response or the outcome is going to happen. So this is the difference between the two when it comes to investigating effect of aspirin on preventing an attack. If effect of aspirin here, that is explanatory variable, and at attack here is the response variable that we can also call outcome variable. Before moving forward, can somebody confirm again, if you can hear me clearly? Is everyone still hearing me?
Yeah, we can still hear you.
Okay, thank you so much. Thank you for confirming that. Now, now we want to focus on design. Okay, and you know what? The reason why we want to focus on design, why we want to focus on experimental design, is actually because of the fact that it has a very, uh, strong statistical power, very huge statistical power. So I want to walk you through some principles that we use in experimental design to guarantee that we have a very good research questions that can be linked to an appropriate statistical methodology that will ensure that at the end of the day, we have results that are valid, okay? Because we don't want to mislead. We want a situation. We will actually want to prevent a situation where we're going to commit resources to research and misleading at the end of the day. We do not want to mislead. And that is why we actually need the principles of experimental design. So, in the principle of experimental design, like I said, it actually provides us, a structure framework, okay, for conducting experiments. Don't forget, like I said, we're in this class today, want to focus on experimental studies. So, how do we conduct experiment? So that causal effects can be estimated efficiently, unbiasedly, and precisely. Okay, so don't forget, our interest here is our goal. We're seeking a causal goal. We are actually seeking an explanatory goal. Okay, we are actually seeking to explain, how a particular variable causes the other. Okay, and we we need to design. We need a principle for experimental design. In order for us to efficiently and precisely estimate that. So, among the principle of experimental design, we have what we call the randomization. We have the use of control group, or the use of replication, the blinding, and blocking. Okay. In today's study, because of our time, uh, we're only going to focus on randomization, the use of control group, and replication. Okay. Because we're still going to use the same material on Monday. So I'm actually going to walk us through the randomization, the use of control group, and replication in today's lecture. Okay, so I want to start with randomization. Okay, I actually want to start with randomization. Okay, so when I say randomization, what do I mean by randomization? Okay, random assignment of experimental units to treatment. So this is what we mean. If I actually have a sample of data, okay, and I partition them into two groups, just like the way Pfizer did, okay, we're actually going to assign the groups. We're going to assign participants to different groups, okay, using equal, instruction of chance. We're going to do it in such a way, that every experimental unit that is the subject has equal probability of getting assigned to any treatment. So, which means when the Pfizer was conducting their clinical trial, you know what they did? They want to ensure that every volunteer, okay, using the study, they can actually uh, be assigned, they have equal chance of receiving either the vaccine or placebo. That's what I mean. They're going to have equal chance of receiving either the vaccine or placebo. There's not going to be uh, any favoritism or biasedness in the allocation. Okay, so that is what we mean by randomization. Okay, so let me tell you this. The reason why in experimental study can be, we can conclude causation with experimental studies because of the fact that we randomize treatments. We randomize, okay, randomization, because the randomization has ability to eliminate any systematic bias. I'm going to say that again. The randomization has ability to eliminate, any systematic or bias, and it's also going to ensure that there's something actually balances, or it balances known and unknown confounders across treatment group. We don't want a situation where the treatment will be confounded. Okay, we really, for us to be able to isolate the effect of treatment, we have to make sure that we randomize. Okay, so, and that was what I was trying to talk about here. Okay, randomization evens out the other differences because there could be other differences among individuals, among the groups, but even though that we know that differences exist among the groups in experiments, okay, but the way we randomize this group for treatment will ensure elimination of any systematic biases between the treatment groups. So that is what we mean by randomization. So in summary, I'm actually going to say randomization actually justify causal inference. I'm going to say that again. Randomization actually justify causal inference. Okay, if I want to make a judgment about causation, okay, because because I've randomized, I can do that. Okay, so it provides a justification for causal inference, and causal inference is one of I'm going to say the major ambition of statisticians, of researcher, that is seeking causal goal. Okay, and that's exactly what I mean. Okay, so because you're going to be conducting independent research, and if you choose to do experimental study, of course, randomization is a key. Okay, now I want to show you. I want to show you this. I want to see the picture here. Okay, um, they are trying to investigate. The maybe they introduce a drug. Okay, they want to test the efficacy of a new drug. Okay, and what happens? Somebody now suggests here, if you take a look at this, he said, can we give the new drug to the rich patients and a placebo to the poor? I'm going to say that again. He said, give the new drug to the rich, okay, and a placebo to the poor, okay. Uh, and he said, no sense getting their hope up. They couldn't afford it even if it works. Now that's it. That's it. That's going to be a bad design. I'm going to say that again. That is going to be a very bad design. Okay, it's a very bad design. Okay, giving the new drug to the rich. Okay, and placebo. When I say placebo, placebo is actually it's more or less like a control. It doesn't have any significant effects. Okay, it's actually being used as a control. Okay, so now if you actually go by this, there's no way we will be able to isolate the effect of the treatment, or maybe the reason between the difference at the end of the day may be as a result of the fact that the rich can maybe have a very improved health condition. Okay, there's possibility. Okay, and that is the reason why this is actually that is going to be referred to as a bad design. Okay, and I said what systematic differences could exist between the rich and poor patient beside treatment. There are other differences that may exist. And you know what is going to happen? That the treatment will be confounded in this. We may not be able to isolate the effects of the treatment if we have done it this way. Okay, if we have actually, if you go by this design, where you give the rich the new drug and you give the poor the old one. Okay, so there's no way, you can actually isolate the effect of the treatment. And that was why I said, there's gonna be confounding. Okay, confounding actually means the treatment is being confounded, okay, in the other differences that may exist between the rich and the poor. Okay, so I just want us to get that. Okay, so and that is exactly, and one of the way, if we really want to prevent any systematic bias, so what we need to do is to randomize. Okay, is to randomize. So randomization will ensure uh, we prevent confounding. Okay, so the randomization we actually prefer confounding. Don't forget, just like what I said the other time. Okay, if the study actually give the real drug only to rich patients and give the placebo to poor patients, okay, there's no way you can tell whether the differences in outcome is due to the treatment or it is due to systematic differences between the rich and poor patients. Let me tell you this, okay? There are underlying differences that are, between that occur between the rich and the poor. The number one is the access to follow-up care. Okay. Number two is the baseline health status, the nutrition. I know the rich is gonna have rich nutrition and the poor we got poor nutrition. What about the stress levels? What about the education? Okay. What about the environmental exposures? Okay. And what about the ability to afford additional therapy? Okay, so the rich will be able to afford additional therapy. So those are the kind of differences, the underlying differences. And in order for us to even out these differences, then we need to randomize. Let me tell you this is not the first time that a mistake was made in research. I remember Professor Cochrane at Harvard University. Then Cochrane was trying to look at the effects of a particular diet on the weight gaining ability of rats. And you know what Cochrane and his students, what they were doing? They were actually, as they assign the new treatment to a tiny rat and the conventional treatment, conventional treatment to fat rats. Okay, some rats they use in the experiment, some of them are fat and some of them are thin. Okay, fat and thin. So they were assigned. They did not use randomization. Okay, in the assignment, and at the end of the day, they were not able to isolate the effects of the treatment. So Cochrane apologized to scientific world. Okay, and he actually acknowledged, the reason why we need to randomize in our research. Okay, so uh, I have another example here where a randomization is expected to work. So, testing the effect of alcohol and sleep deprivation on driving ability. And each drivers went through all four treatments. Okay, based on the design, we got some design, different type of design. We have that we can actually talk about. There's completely randomized design. There's randomized complete block design. But here they're using what I call the randomized complete block design. Okay, where every driver has to pass through the four treatment. These are the four level, the treatment, the no alcohol plus rested, alcohol plus rested, no alcohol plus fatigue, and alcohol plus fatigue. And of course, here we notice that without randomizing the order of the treatment, okay, the drivers are likely to do better on the fourth drive. Okay, so but if we so making the order random averages out the learning effects over the four treatments. So the randomization will actually eliminate systematic bias here. Okay. And I said, if you take a look at the fourth run, the fourth treatment, we have more practice and they will likely perform better without randomization. Okay. Or they may be more tired, making the later trial worse. There's possibility because each driver will have to pass through the four treatment. Okay. So either way, okay, the order now becomes a confounder. Okay. Because you can tell if the performance changes are due to the alcohol fatigue or simply doing it four times in a row. Okay, so randomization or preferring what I call the systematic or bias. Just wanted to understand that. Okay, so because we'll be talking about randomization, what is the difference between random sampling and randomization? Okay, when I say random sampling, okay, I'm actually talking about one of the sampling techniques. The way we with the way we select our data. For instance, we want to conduct a study. Okay, let's say we want to conduct a study, and the study has to do okay, the same way. Let me use the Pfizer the clinical trial conducted by Pfizer company. Okay, I want to believe they selected 80,000 individual as some of them are volunteers. Okay, if they have done that randomly, okay, maybe out of so many people in the world, okay, they randomly select 80,000. That is random sampling. They use random sampling. Okay, when you randomly sample units from the population is actually the totality of the units. Okay, you now choose from the population. Okay, that is what we call random sample. Okay, in such a way that every member of a population has equal probability of being chosen. Okay, then you're actually using what I call a random sampling approach. Okay, now when you take a sample from a population, at the end of the day, statistical inference implies that I want to generalize the result that I got from the sample on the entire population. And that is why you see we want to extend result to a larger population. Okay. So that is that. But when I talk about randomization now, the randomization is going to be a second stage. Okay. The second stage in the sense that we have taken our sample randomly from the population. And then the sample that we have now will be actually splitted into groups. And when they are splitted into group, then we can assign treatment to the group using instruction of chance in such a way that each unit in the sample has equal probability of getting assigned to any treatment. That is randomization. So what I've demonstrated now, okay, so what I've demonstrated now, randomization is different from random sampling. Okay, random sample is when you randomly select individuals from the population, from the target population, in such a way that you give equal chance to every unit in the population. Okay, But the randomization, on the other hand, is talking about random assignments of the treatments. Okay, how you assign the uh individuals in your sample. Okay, individual in your sample, individual you have grouped into you've grouped into groups, how you assign them to treatments. Okay, and that is what we call randomization. So, and of course, the intention in randomization is to answer a question of causality, is to establish what I call the cause and effects. But why in the random sample is just to extend the result to a larger population. So I just wanted to take note of that. Difference exists between randomization and random sampling. Okay, now before going into the use of control group, is there any question at this time? I need somebody to confirm again if you are still hearing me clearly. Is everyone still hearing me?
Yep, we can still hear you.
Okay, thank you so much. Thank you for confirming that. Now we want to talk about the use of control group. Okay, now when we talk about control group, we are actually talking about, when we have a group that will receive treatment, we also need to have a group that will receive placebo. Okay, the group that receive placebo, it's like we want the control group to serve as a baseline for comparison. It's like I want to compare intervention with nothing. I'm going to say this, it's just like without mitigation, okay, what is going to happen? Okay, I remember during COVID, we are for instance, if I don't do social distancing, if I don't wear mask, if I don't get vaccinated, okay, so what is going to happen? Okay, so if I don't wear mask, if I don't uh practice social distancing, if I don't get vaccinated, okay, we can actually compare that with those who get vaccinated, so the control group will serve as a baseline, okay, for comparison. Okay, it's like you're comparing your intervention with nothing. Okay, and let me tell you, the control group is should be handled identically to the treatment group because uh you know we actually wanted to look as uh if you are given a placebo, we want it to look as if you are getting the real treatment. Okay. Want it to look as if you are getting the real treatment. So we don't want a situation, we don't want to give the patient, or we don't want to give the subjects in our sample, uh we don't want to let them know that they are receiving placebo. Okay. We want it to look as if they're getting the real treatment. Okay. So that is that. Now I'm gonna walk you through an example. Okay, I just wanted to take note of this. A research team want to study the effect of the amount of fertilizer on crop yield. Okay, they actually want to investigate whether fertilizer work or not. Okay, and they have 4 treatment group. They have no fertilizer. Okay, they have one AB fertilizer, 2 AB fertilizer, 3 AB fertilizer, and of course, each treatment was applied to 20 plots. Okay, the plots here are the experimental units. I'm gonna say that again. The plots here are the experimental unit. Okay, they are the one they're gonna receive treatment. Okay, now I want to award an extra credit now. Can somebody tell me treatments? Which of these 4 levels of treatment correspond to the control group? Can somebody tell me? For extra credit.
No fertilizer.
Thank you so much. Send me a message for extra credits. Let me tell you about extra credit. Um, if you answer my question correctly in class, you're gonna have one extra credit. okay? One extra credit point, okay? So, and you can accumulate that throughout the semester, and the moment the final result is in, you're going to advise me on how you want to spend your extra credits. Okay, somebody that answer my question now as an extra credit of 1 point. Okay, so no fertilizer correspond to the control group. Okay, now a study must be designed in a way, okay, that we're gonna have a control group. Okay, let me see. I think I have a chart. I received a chart. Oh, okay, okay. Thank you so much for answering that. Okay, so I want to go into placebo now. Okay, let me tell you this. Uh, placebo is what we normally give to participant or in the control group, the experimental unit in the control group. Placebo is a special kind of, of a drug. It's not, it doesn't really have effects. But let me tell you this. Several studies have shown that it can also be quite effective. Okay, I'm trying to give you literature here where studies show that up to, it's help the headaches suffer up to 62%. Okay, and 58% of those suffering from sickles, seasickness, and 39% of those with postoperative wound pain. Okay, but it's not that significant. I remember when I was in college, whenever I look or maybe whenever I have a pain, okay, I'll just I'll go and play soccer, and the moment I play soccer, I'm okay. Okay, I didn't use any no drug at all. I didn't take any medicine, but I'm gonna be fine. But even though it can still come back, so when I say placebo effects, okay, we're actually talking about the effect that result from the participant believing that they have received an active treatment. Okay, because when they give them placebo, they actually going to believe that they are being given the real treatment. Okay, so it's psychological for from what I've seen. Okay, now lastly, before I go today, I want to talk about this example. A study was conducted. They recruit or social media. This is a social media study. The researchers recruited 30 volunteers to study the effects of social media usage on stress. Okay. The researchers survey the volunteers about their stress level using a validated survey at the beginning of the study. Then all volunteers were instructed to download a program that blocked the social media site for 30 days in their electronic devices. After 30 days, the researchers surveyed the volunteers about their stress level. Now, I want to ask a question. Does this study have a control group? Can somebody answer that question?
No, they
Does this
don't.
study have a control group?
Oh, they do not have a control group.
Thank you so much. Send me a message for extra credit. Now, I want another person to tell me, why do you think so that this particular study does not have a control group? Can you give reason? Can somebody give reason?
Is it because that it's studying like people are going to have varying levels of social media like usage? So there's not really one standardized control group that where everybody uses like 1 hour of social media. It's more like everybody is just very highly varied.
Okay, so you that is one of it. You're very close to the answer. I'm also going to give you an extra credit too. Can somebody tell me, okay, in this case, what do you think the control group would have been? Because the treatment group is that they ask all of them to block the social media site for 30 days, all the participants. So what would be the control group in that regard?
Maybe a
It-
control group would be a group that never used social media prior.
A group that never used social media. Okay, this is what happened. Uh, some have some the group that never use social media and those one that use social media, okay. In this study they block them. They say they should block the social media, which means for the study period they're not going to have access to social media. So the control group in this situation is when they also have a group that continue to enjoy the social media, that didn't block the social media. So that would have been control group here. Okay, the control group we have been, okay, some will block social media and some will not block social media. But for those of you who have actually responded today, or you have actually done a very great job. Okay, so this is where I'm actually gonna stop today. On Monday, we're gonna continue from where we start. We're gonna continue from replication. Is there any question before I go today? Okay, so we're actually gonna resume in-person teaching on Monday. I'm hoping the weather is gonna be fine. If any one of you is going out, okay, it's extremely cold outside there. Okay, make sure you dress warm. Okay, have a nice weekend. See you on Monday. Bye for now.